The Foundations of Geometry by David Hilbert.
Chapter 6, Pascal's Theorem. Section 34, Proof of the two propositions concerning Pascal's Theorem, Non-pascalian Geometry. If in a geometry of space all of the axioms 1, 2, and 3 are fulfilled, then Desargues' theorem, Theorem 32, is also valid, and consequently, according to sections 24 through 26, pages 50 through 58, it is possible to introduce into this geometry an algebra of segments for which the rules 1 through 11, 13 through 16 of section 13 are all valid. If we assume now that axiom 5 of Archimedes is valid for our geometry, then evidently Archimedes' theorem, Theorem 17 of section 13, also holds for our algebra of segments, and consequently, by virtue of Theorem 38, the commutative law of multiplication is valid. Since, however, the definition of the products of two segments as introduced in section 24, figure 42, and which is the definition here also under discussion, agrees with the definition in section 15, figure 22, it follows from the construction made in section 15 that the commutative law of multiplication is here nothing else than Pascal's theorem. Consequently, the validity of Theorem 36 is established. In order to demonstrate Theorem 37, let us again consider the Desarguesian number system omega st, introduced in section 33, and construct in a manner described in section 29 a geometry of space for which all of the axioms of groups 1, 2, and 3 are fulfilled. However, Pascal's theorem will not hold for this geometry, for the commutative law of multiplication is not valid in the Desarguesian number system omega st. According to Theorem 36, the non-pascalian geometry is then necessarily also a non-Archimedean geometry. By adopting the hypothesis we have, it is evident that we cannot demonstrate Pascal's theorem, for we regard our geometry of space as part of a geometry of an arbitrary number of dimensions in which, besides the points, straight lines, and planes, still other linear elements are present, and providing there exists for these elements a corresponding system of axioms of connection and of order, as well as the axiom of parallels.
The Foundations of Geometry by David Hilbert. The material contained in the following translation was given in substance by Professor Hilbert as a course of lectures on Euclidean geometry at the University of Göttingen during the winter semester of 1898 and 1899. It was translated by E. J. Townsend, Ph.D., University of Illinois. The text was downloaded from Project Gutenberg with the following notice: this ebook is for the use of anyone, anywhere in the United States and most other parts of the world at no cost and with almost no restrictions whatsoever. Read by Jim Renholt. Programming and illustrations by Jim Renholt. 2019. Portrait of David Hilbert by Rita Ray Renholt. Thank you for listening.